I'm working at Fleet Health. We do a lot of natural language processing, the kind of thing that can take a while, because you tweak your model, you train your model, you wait around for a while and test it. And yeah, my boss is just technical enough to be kind of a pain in the ass sometimes. So one day while waiting around for things to train and get back to me, he suggested that I take advantage of the multiprocessing functionality in Python. Make it go faster, sit around less. And I didn't really want to, because my mental image of multiprocessing code was very complicated. I was thinking of like locks and shared state and like threads going all over the place, and I didn't want to have to re-engineer my code. But he kept at it, and so to shut him up, I looked into it. And it ended up being a lot less complicated and intimidating than I realized it would be. So what I'm hoping to do today is kind of share my experience with it and reduce the intimidation factor for some of you guys. So with that said, you guys have probably heard of the global interpreter lock before. That definition that I pulled up here, not very helpful to me. I don't use words like mutex and thread safe in daily conversation. Sure. Is that good? Yeah. All right, hopefully, down a little bit. Hopefully the code blocks will still fit. This is Jupyter, by the way, that's been talked about. So what it actually means is that in practice, there's a couple different ways of doing multi-threading in Python. There's a multi-threading module. There's the new async await features. But if you're just using those, you won't actually be able to take advantage of having multiple CPUs. Anything that is CPU bound will block. And so things like reading from the file system, making web requests, stuff like that, you can parallelize very easily. Anything that's more algorithmic or kind of inside of your Python process, that'll block and you can't really distribute that as easily. But there are a couple ways to get around that, and that's what I will be talking about. So to begin with, I figured I'd start with a pretty basic MapReduce problem. I've created a kind of fake log file. It's a bunch of lines of JSON. I can make that bigger too. They have an IP address, the time the thing occurred, and what path people were asking for. And so this is 1 million lines long. JSON deserialization is actually kind of slow for what it's doing. So I figured this would be a good place to start. So this block of code here is entirely synchronous. And when I kick it off, it has to read the file off the file system. I've got a kind of map method in there for pulling out just the IP address, and then I'm counting out which ones were the most common. This was a generated file, so they're all basically the same. So that took 8.5 seconds to complete. And here I have what is essentially the same thing, except it can take advantage of having multiple processors. So of note, this machine only has 2, so it's not going to be a whole lot faster. But I've found that this number right here is how many processes I'm telling it to use, and giving it more than I actually have seems to make it go a little bit faster. But if I run that. Okay, and so yeah, the same results, but as you can see, it happened close-ish to half the time. So that's useful. It's not a lot of fun. IP addresses, request logs, they're kind of boring. And because there's so many records and it is still kind of fast, I think that script anyway is doing more overhead, just pulling things out of the file and making processes and shutting them down than it is actually doing the calculation. So I wanted something more interesting, something that might take a little bit longer, and something that would show examples on the screen. So I was thinking image processing. So I'm just going to run that. I created a method, or a library, a very small one, that will take an image and convert it to an ASCII art image. So I have my girlfriend's cat, beautiful cat, and so this just ran. It took 2 and a little bit more seconds, and it made there's probably a resolution that does there. That's the best we're going to get. But there you go. So that was fun. There we go. Yeah, so putting that together was pretty interesting. You just kind of take, you can grayscale the image, you figure out what the pixel value is, and then you map those to different symbols of different weight, and so you can stitch the images back together. So that's just one picture of one cat. How do we kick this off to multiple processors? And so for that, we have animated GIFs, which are the best thing in the world. So again, this is the synchronous version. It takes about 2 seconds to turn this GIF of a cat playing with a water balloon into an ASCII art version of the cat playing with a water balloon. And you can kind of just see the black bob jumping up and running away, but it was fun. So as you can see in this code, it's not doing anything really sophisticated. I've got a method for reading every frame out of the image, and then I'm, let's see, where we go, converting each frame one at a time into an ASCII art thing, and then down here, right frames stitches them back together. So when I said that I imagined that multiprocessing code would be a huge mess, this is kind of what I was picturing. I wrote this like a week ago, and I can't really follow it. It's doing the exact same thing as the block of code before, but I've got this queue here. Manager is for if you do need to share state between different processes. I've got to explicitly create each process and tell them to run this method, and it's got the queue and it needs to finish. It's crazy, but this is using the Python multiprocessing module. This is in the standard library, and when you run it, I'm going to run it again. When you run it, yay, it takes about half the time, 1.22 seconds as opposed to 2.15. So this is kind of what I had in mind and the reason I didn't want to go down this rabbit hole. That's all well and good. There's also, if you have kind of longer running calculations than the kinds of things that I'm looking at there, you may have heard of Celery. It's a pretty commonly used library for distributed processing. But for me, it's got a lot of overhead. Luckily, this code is about 1 million times simpler than this. But to run it, you need to be running Redis server or some other kind of message broker. You need to have the Celery worker environment running. And so that's all running. And so now when I run this, it takes even longer. And so the problem here is that what it's doing is it needs to run everything through Pickle, and then it needs to send it off to the Redis. It needs to pull it back out of the Redis. There's just a lot of overhead in this process. And so if you were doing something that took longer per task, then this would be very efficient. But because of just kind of that constant overhead, you don't get a whole lot out of it. Yeah, so that took longer. And finally, this is what I've kind of found to be a really useful pattern when working with the multiprocessing module. There's this concept, or this class that Python provides called pool. And what you can do is you tell it the number of processes that you want. You can use the standard with open to open things. And then you've got this object MP. MP has a couple useful methods on it. In this case, I'm using map. And so I'm able to kind of go back to this example of the synchronous code. And I'm doing something that's basically the same, except it can push this function call off to separate processes. So when I run that, and because it doesn't have me managing state, I'm not creating queues and managers and things like that, it can actually run just a little bit faster than my original complicated example. So if you're planning on working with multiprocessing, or you were avoiding it before, this is a really good place to get started. And so just to prove that it does work, this is a different one. So there's a couple different utility methods on the multiprocessing, like the pool of processes that gets created. Map seems to be kind of where it kind of goes off of. There's another one, IMAP, which returns an iterator. So you can create the iterator and then not actually run it until later. There's one that's even that if I can spell, ordered. So this one here, it should be, okay, so this should be the fastest, but it's stuck or something like that. What it does is it returns an iterator, and when it's mapping over things, it doesn't necessarily return them in the order that they were passed in. So if the order of your list of things to be processed doesn't matter, you can use this one and really just take advantage of, let the CPU organize itself however it wants. What is it stuck on?
Does this have any notion of mutex?
I'm sorry?
A mutex or any way to handle shared state or blocking?
So with the pool and the map method, as far as I know, no. You can't really share state. It's really a very take an input, return an output. If you want to share state, then you do have to start looking at these things. There's the manager. What it can do, it's another class inside the multiprocessing module. What it does is it provides kind of shared stateable primitives. So in this one I used a list to kind of load all the processed frames into. And so this can be passed into, so L gets created there. And so when this one creates a process, it's told to run runner. You can pass the list into it there. And so yeah, the module itself does have capabilities for shared state. But as much as possible, I'm much happier not worrying about shared state. It's the kind of thing that can get hairy very, very quickly. So I'd kind of recommend avoiding it unless you really, really need to. So that actually goes to my next point. So with the map function, you can't share state with, what happens is every process that gets created with more or less a copy of your current environment. So any variables or functions that you've already defined, they get passed into it, but whatever you do to them doesn't get passed back to your original environment. So to kind of show that in action, this is all screwed up. So this has never happened to me before using Jupyter. So yeah, so this is the synchronous code. I'm just kind of adding single integers to my array and then printing it out. I need to this one. And so this would be the multiprocessing version of attempting to do the same thing. Notice that bar is defined outside of kind of the add to bar method. So when you run it, what happens is this add to bar method, it has its own copy of bar. And so it thinks that it can write to it, but each process is writing to their own copy, and so the main process doesn't have anything left in it. And so, yeah, this has ended up being a much shorter talk than I had planned for it to be, but really the simplicity of the Python module kind of cut out my talk for me. So this notebook is on GitHub if you want to play around with it. And yeah, if anyone has any questions, happy to go into it.
I was curious about
Sure.
Something that was standing out to me was the percent time
Yes,
syntax. Is that a Jupyter thing or?
that is a Jupyter thing, yeah. Thank you. Yeah, what exactly is the difference between IPython and Jupyter?
Well, IPython is an augmented interpreter for Python.
Okay.
And then Jupyter
Is the
talks to
web
IPython.
GUI?
Yes.
Okay. Yeah. So anything that starts with percent is kind of a IPython magic method. And what time does is it counts how long it takes to run the line that it's on.
Kind of like a decorator, sort of.
Yeah, a little bit. Most of the magic methods don't work like that. So you'll notice that most of these blocks don't actually have an import at the top of them. They kind of remember things that are defined in other cells. But one of the disadvantages of that is that it doesn't re-import modules for you. So if you're working on something outside of it, you need to change it. So there's like an auto reload one that'll kind of tell it to go out and re-import stuff for you every time. Yeah.
Will any of the methods that you use take advantage not only of cores, but of multiple threads, like a hypervisor, multi-threading hardware architecture?
I think that if you already have multi-threading kind of embedded in it, like in your code, and then you tell it to also use the multi-processing, like the multiple processes, as far as I know, that should work just fine. When I've run this with like process monitor open, it just kicks off new Python processes. So I don't see any reason why you wouldn't be able to use multi-threading in addition to multi-processing. It would probably get pretty hairy.
Were you able to do a test that is just to isolate the I/O component on this? You've got the test that runs. Okay, I'm going to convert this, from JSON, extract the data out of it. But to be able to isolate, when you've got wall time of 5 seconds, is it safe to assume that most of that's going to be I/O, I/O time, that kind of thing?
So all of these, I've structured my code so that the actual reading of the file is happening outside of the timer.
So reframes, well, that's the...
Yeah,
that's
so,
the diff.
yeah, the with image open as image is actually opening and parsing the GIF into something that's already in Python. Read frames, so there's a little bit of overhead there, but it's basically taking a GIF that's already been processed and then pulling out each frame individually. So
You had a million lines of million lines of log file that you'll read in a different test?
Yeah, that one, way up here. So handle read lines, yeah. So this one, that is probably actually why it's taking 5.5 seconds as opposed to the, like an actual half time. That makes sense. Yeah, about the, oh, sorry, yeah, you have a question. Okay. I was going to say about the GIFs, I was really surprised to find that reading and writing animated GIFs, apparently no one's tried to do that with Python since 2.7. None of the libraries work. I had to go in and read about the file format, and I think I spent more time learning about animated GIFs than I did learning about multiprocessing, so I should have talked about that. But
You're gonna post an update to Python?
Well, there's just like these little libraries out there that people have written and then not maintained in like 10 years.
You'll find that a lot. I mean, it's right now, Twisted's been recently ported to Python,
Mhm.
to Python 3, and there's tons of useful modules for Twisted, and you really like them to be in Python 3, and it's gonna be a ton of work.
Yep.
There's a lot of stuff to convert, so,
Yeah.
you know.
So yes, you did have a question.
So I guess two quick questions, maybe share your experience, I'll share mine. When you're mapping over your pool,
Mhm.
I've had one that's pretty long running, and so it seems kind of a 2-core processor that has hyper-threading. So it ran for 20 hours or so, and what happened was, when you pushed it out, you pushed out all the work at the very beginning.
Mm-hmm.
So that if you had some of your log files were shorter, whatever your files, some were shorter and some were longer, it would run all 4 processes until one of them finishes and it drops off. Then you have 3 and it drops off. And you get down to the end, you still have 1 process running. So this is kicking everything off kind of statically at start there. You need to be a little careful of that, is what I found.
Okay. So my understanding of what's happening here is that Python with the pool, it creates a pool of processes and kind of assigns a method to each one. So in this case, it's the getIP method. And then as they finish, it goes to the next thing from handle read lines. So especially with the IMAP unordered, that unless you have exactly as many like things in your iterator as you do CPUs on your machine, I don't think that would be much of a problem. That it shouldn't assign new tasks to, like it's not going to divide all the tasks up front. It's going to wait until there's an opening and then assign a task to it.
Okay, so I was using MAP, not IMAP, but
Okay.
that was my experience. I didn't know how big of a process you'd run or how long-running multi-process thing you'd run if you'd see anything like that. So
Yeah, I've been running pretty short things for the most part, so I haven't run into that. But yeah, I'd take a look at the other methods on the pool because IMAP unordered sounds like exactly like it's designed to solve that kind of a problem.
and my other question was, to Mark's other question, have you dealt much with this multi-processing where you have aspects of your program which are I/O bound and aspects that are CPU bound, and kind of how to partition that up in a reasonable way so that you're taking advantage of the CPU, the multi-processors to do the CPU bound stuff, but then not starving each of those with one I/O.
Yeah. Most of what I'm doing is reading in a file, doing something to a million lines, and then writing out either a new file or usually a new file. So not especially. It's kind of a this, then that, then this. There's not a lot of in-between interaction there. So yeah, I can't help you, unfortunately, with that. But, yes?
You said copies were made, and that's actually an issue when you have something really big and you have, say, a lot of cores.
Mhm.
You actually don't want to make 8 copies of your 2 gigabyte matrix. Is there a way to tell it, no, this is read-only, don't copy it?
That is a really good question. No? Yeah.
You could use shared memory segments or something like that. You're using
Yeah.
Second question, you're a data scientist, I think. I'm not discounting the importance of kit and gifs
Mhm.
for a moment, but how do you use this? How do you effectively use this?
So when I've been using this, it's been for we do a lot of natural language processing. And so we end up with these corpuses that are full of all kinds of garbage a lot. So punctuation or just too much white space, things like that. And so actually a better example is we recently had to anonymize a bunch of text. We're in kind of the medical space, so HIPAA stuff. And the anonymization software that I'd written was taking a little while. And we found that with this, we were able to kind of like take blocks of text and say, go anonymize this. And so that was useful because that ended up being like a fairly labor-intensive process. We had a list of names that we were going through, and then a list of like cities and addresses and things like that, and then some just like really heavy-handed regular expressions. And we needed to run every single one of those things on every single block of text. And so that ended up being a very kind of computationally expensive thing that we wanted to hand off. Yes?
Do you now find yourself looking for places to implement this, like looking back at your code and saying, hey, you know what, I can improve this or that? And is that something that, once you kind of did this paradigm shift to multiprocessing, are you kind of just...
I'm definitely a lot quicker to jump to it. So, you know, you have to think about your code as a map instead of a for loop. I've done some kind of functional-ish programming, so that's not a huge leap to have to do all the time. Yeah, so I'm definitely a lot more inclined to say, all right, this is a situation where I can, you know, anytime that I'm spending more than like 10 seconds on something, definitely kick it off. I need a beefier machine to really one of the quad-core processors, but yeah.
So, this is a kind of a do you understand why question, but image processing, why doesn't it release the GIL in the C code? Because like if you did this kind of type of stuff, the number crunching stuff in NumPy,
Mm-hmm.
you can watch the CPU loads jump to 300, 400, 800%,
Right.
right?
Yeah.
If you've got an 8-way machine, it'll use all of it.
Mm-hmm.
Why didn't Hill?
So the answer is probably that I'm the one who wrote the ASCII conversion function, and it's in Python, it's not in C. As far as I know, there isn't a C library for doing that, although you could probably do it with NumPy, just because of the types of operations that it's doing. So it's a pretty simple method, so I didn't spend too much time looking at different ways to improve it.
So you're saying Pill does release the GIL?
I would assume that the C code would release the
Yeah,
GIL.
I hope so.
Yeah. Pill is really just getting me pixel data here. It resizes the image. That probably does release the GIL. But most of what I'm using Pill here for is getting the actual pixel data. And then I've got to map that out with Python. All right, well, I think that looks like everyone. So thank you very much.